Hello everybody, welcome back. We're going to be looking at a brand new contest in this video. We're going to be looking at the 2011 Friar contest. So still the usual 4 questions at a grade 9 level. Click the link in the description. You can find the link to the Waterloo website, the people who put out these contests. And you can look at all their past contests, including the 2011 Friar, the one we're going to be going through. Feel free to try the contest ahead of time, and that way you really understand what the questions are asking and see how well you would do before you come back here and see how well I do. So let's take a look at the question number 1 together. An arithmetic sequence is a sequence in which each term after the first is obtained from the previous term by adding a constant d called the common difference. For example, 2, 5, 8, 11, 14 are the first 5 terms in an arithmetic sequence with common difference of d equals 3. So this question has 4 parts to it, and hopefully you've paused the video and had a go for yourself. A. Determine the 6th and 7th terms of the sequence given above. Okay, well we have the first 5 terms, and we know that to get each new term, we just add on our common difference of d equals 3. So, let's grab ourselves a little solution booklet here. So to figure out the 6th term, we start off with 2, 5, 8, 11, 14. So the 6th term is the 5th term plus d. So that's 14 plus 3. That's 17. The 7th term is the 6th term plus our common difference of d. Well, we just figured out what the 6th term is. That's 17. We add on 3, we get 20. So there are our next 2 terms, 17 and 20. Okay. What is the 31st term in the sequence? That's what question B is asking us. Alright, so that's a little harder. We could probably either get out our calculators or by hand work out the next few terms in the sequence all the way up to 31. But as it turns out, there's a formula for arithmetic sequences that hopefully you've seen before. If not, I think I'll do a video on it, or you can probably find a resource online about it. But there's definitely a formula. So if you haven't seen it before, this is what it is. So if we have common difference d, and the first term, if we call that a, let's draw our a little better. So the nth term is a plus n minus 1 times d. Okay? So if you haven't seen this formula before, that's okay. Take a moment and try and verify. We know that for this sequence, we start with 2. So if a was 2 and n was 1, 1 minus 1 is 0. So it would just be 2 plus 0 times 3, that's just 2. You can check it out with 5. 5 is the second term, so n would be 2. 2 plus 2 minus 1 times 3. Well, that's going to be 2 plus 3. That's 5. You can try it out with some of the terms we just computed. The 7th term, 2 plus 7 minus 1 times 3 is 2 plus 6 times 3. So that's 2 plus 18. That's 20. And that's exactly what we got. Okay. So if we want the 31st term, so 31 minus 1d, well, a is 2, and d is 3. So that's going to be 3 times 30, that's 90. 2 plus 90, 92. So now we know what the 31st term in the sequence is. And if you haven't seen arithmetic sequences before, this is a formula that it pops up from time to time. Arithmetic sequences, geometric sequences, they do pop up on these questions. And in general, in mathematics, number theory, combinatorics, it occasionally pops up. So it's something you might want to know. And so there's our formula. We've written it out in a nice clean sentence. And something to take away. If you've never seen that before, if you tried this question and this was a stumbling block, it took too long to answer this one, this is a formula you can take away, you can know, and if you write it out, as long as you explain what you're talking about, if you write out that this is the formula for the nth term of an arithmetic sequence on a future contest, they're not going to ding you marks on this. This is a common math thing. Alright, so C part. If the last term in this sequence were 110, how many terms would there be in a sequence? In the sequence, sorry. So 110 is in the sequence, and it's the last term. So if we figured out that 110 was the 50th term, then 50 would be the number of terms in the sequence. So we need to figure out n so that 110 is the nth term in the sequence. So we can apply our little formula here. So we get 3n minus 1. So 3n is going to be 111. And that tells us that n is going to be 111 divided by 3. And I believe that's 37, but we can just double check that. Yep, 37. And since 110, the one we just figured out, is the last term, that tells us that there are going to be exactly 37 terms in the sequence. All right. So that's C part dealt with. How about D? If this sequence is continued, does 1321 appear in the sequence? Explain why or why not. Okay. Well, if it does, then it's the nth term for some n. Maybe it's the 500th term or the 5,000th term, something like that. So let's suppose it is in the sequence. Then we can find some integer or positive integer n so that 1321 is the nth term in the sequence. Now, if it turns out that we can't find such an n, we'll know that our assumption that 1321 appears in the sequence is false. Right? If we assume it's the nth term, let's try and find out what n is. So just as before, we can argue this down to 3n minus 1. A is 2, d is 3. So then 3n is going to be 1321 plus 1. And that's 1322. So n is 1322 over 3. Now, the sum of these digits, 1 plus 3 plus 2 plus 2, that's 8. That's not a multiple of 3, so I can already tell this isn't going to work out. But we can check by calculator. This is 440 and 2/3. So this is what's known as a proof by contradiction. We assumed something, it gave us a gibberish answer. So something that makes absolutely no sense. You can't have a 440 and 2/3 term in a sequence. The term numbers have to be positive integers. You have a first term, a second term, a third term, a fourth term, a 440th term, sure, but not a 440.66666 repeating term. So we contradicted our assumption by getting a nonsense answer out here. Okay. So, since our assumption must be false, so that was our assumption that it appears in the sequence. We know that that's false, so the opposite must be true. 1321 does not appear in the sequence. Plenty of other sequences it might appear in, but it's certainly not this one. Okay. And all of that came basically from remembering the formula for arithmetic sequences. Now, if you don't know it, commit it to memory, because it is certainly a fair game on a math contest. It really is. It's also something you could probably derive for yourself, but we'll save you a bit of time and just give you the formula in a nice, concise form. That's D part. That's all of question 1. So it's a nice quick start to the 2011 Fryer paper. I hope you enjoyed it. If you did, give a like on the video, and hopefully you'll continue to enjoy as we continue through the rest of the contest. I'll see you guys for question number 2 in the next video.